Let's consider a problem. Let's say that we have an array of size 4 with values 1, 2, 3, and 4, and we want to insert a value, let's say 2.5, between the second and third elements. How would we do this? Well, first we'd have to create an array of size 5, copy over the first two elements, copy over the element we're trying to insert, and then copy over the remaining elements. This is a lot of work for a seemingly simple task, especially as the length of our array increases. This is because elements in arrays are stored continuously in memory, meaning that elements are stored one after another. To visualize this, let's pretend this is our memory. An array, or a vector, would have its elements stored one after another. Not all containers are like this, though. For example, in a linked list, elements are still in an order, but they are not stored sequentially in memory. Instead of the next element being stored in the next slot in memory, the element contains a pointer to the location of the next element. So, in memory, a linked list could look something like so. You could still have all of the same elements, but you would just maintain order via pointers. Elements in linked lists are usually represented by nodes. The node struct often includes a datum value, which in our case would be a double, a node pointer to the next element, and in the case of a doubly linked list, a node pointer to the previous element. If this list was doubly linked, there would be a previous pointer between 4 and 3, a previous pointer from 3 to 2, and a previous pointer from 2 to 1. Now let's consider the problem we were talking about earlier, but with a doubly linked list instead of an array. We would still have 4 elements, represented by nodes, with datum values 1, 2, 3, and 4. The next pointer of 1 would be pointing to 2, the next pointer of 2 would be pointing to 3, the next pointer of 3 would be pointing to 4, and the next pointer of 4 would be a null pointer. The previous pointer of 4 would be a pointer to 3, the previous pointer of 3 would be a pointer to 2, the previous pointer of 2 would be a pointer to 1, and the previous pointer of 1 would be a null pointer. Now let's create a function that would insert an element into our linked list. Let's call it insert, and let's have it take in a node pointer to the prior element, which in our case would be a node pointer to 2, and a data value, which in our case would be 2.5. The first thing we have to do is create our new node. We use the new keyword because we're going to be working in dynamic memory. Next, we have to make its datum value equal to the value that we desire, which in our case would be 2.5. We have to make its next pointer a pointer to 3, which in this case is the same as the next pointer of 2, so prior next. We would have to make its previous pointer a pointer to 2, which is the same as prior. We also need to make the next pointer of 2 a pointer to 2.5. So we need to make prior next equal to current. We also need to take the previous pointer of 3 and make it a pointer to 2.5. Our only way to access 3 is by using the next pointer of 2.5. So this is a pointer to 3, and we want to make its previous pointer equal to current. While this is a general algorithm to insert a value into a linked list, looking closely at this function, it does not work when we are trying to insert a value at the end of the list, because we would be dereferencing a null pointer here. In our next video, we'll discuss a way to account for this problem. Thanks for watching, and see you next time.